Hey everyone, my name is Kainz and today I'll be presenting on the AI tutoring bot. So, a little bit about me. I'm currently a software engineer at Microsoft working on the OneDrive SharePoint AI team to improve OneDrive SharePoint's Copilot system. Alongside that, I'm currently pursuing a Master of Science in Computer Science at Georgia Tech and I'm specializing in machine learning. I also got my undergrad in computer science from Vanderbilt this past May. So, here's a little bit on what my project actually is. I wanted to create an AI-powered tutoring system that allows students to submit their handwritten notes, papers, past exams, and also current books in the form of PDFs and allow them to interact and study with them um, through an AI system. I used several different data science topics here, including fine-tuning of a base PaliGemma model, as well as the application of a visual-based RAG system called ColPali, which was built on PaliGemma, and also used a metrics and large language model-based evaluation approach to test my fine-tuning. I'd say overall the biggest thing I learned was the actual process of fine-tuning a model. I never fine-tuned a model before, and it was a really cool experience to me to see it actually working and making an improvement in the large language model's output. So, for data collection, I reached out to several different people and got over 1,000 different kind of notes in different subjects and finalized on 900 question answer pairs. I generated these question answer pairs by taking the handwritten notes and using GPT-4o Vision to kind of get meaningful information from each page. Then I split for a training and testing set and went on to fine tuning. From there, I took a base PaliGemma model and used our training data to fine tune our model to get a specialized AI tutoring bot. Then I evaluated both models via metrics-based evaluation and a model-based evaluation to see which one kind of fits our use case better. So in our results, you can see that our fine-tuned model did a much better job on the testing data. You can see, especially in the model-based results, that we got a much higher mean score than the base model. We also improved on the computation-based results as well, though not as much. Overall, though, I'd say this is a huge win considering the big jump we made and the fact that model-based comparison is probably a better evaluator overall. So, how does the kind of data flow work and what is our tutoring bot actually doing? Well, first, the user can submit all of their handwritten notes, books, or previous exams in the form of PDFs alongside a user query. Then we're going to take our query and user data and go to ColPali, which is a visual-based RAG system that vectorizes pages and then allows you to find the most relevant pages based off the user query. We're going to do this with all the user notes and find the top relevant pages for to generate our study guide from. From there, we're going to take these top pages and bring them to a base PaliGemma model that's able to convert images into text. Then we take all of this generated text from our top relevant pages and bring it to our fine-tune model. Then we're going to prompt our fine-tune model for question and answering and get all of our questions and answers and generate a study guide in the form of a TXT. You also can see the ColPali model below, and I also included a link if you're interested. So here's an example. On the top, you can see we have the search space that the user defined, which is just all of their notes. And I think that's over 150 different pages in there. And then from there, we're going to write a query and say, like, we just want to learn about vectors. So the user inputs vectors, and it's going to search all of their notes on linear algebra, organic chemistry, biology, and infancy, and find the most relevant information on vectors. From there, it's going to generate question and answers and output a .txt. Here you can see what the final output would look like for the user. And we have very good question and answers, and you can kind of read through it and see that the large language model did a good job at kind of helping the user learn about vectors and kind of giving them a good guide on what they need to understand. It's worth noting as well that this model can be used in a conversational setting, with just a little bit of changing how the information flows. The user can just kind of speak directly to the model and ask questions on their notes if they're interested in that as well. Also, this could potentially be leveraged, this study guide, to produce flashcards for the user if they were to want that as well. Here's all my projects links. I have all my code in a GitHub repository and also publish the fine-tuned model as well to Kaggle. Thank you to the entire KaggleX team for making this project possible. I had a great time kind of understanding and learning the process of fine-tuning a model, and it was a really fun experience. Also, thank you to Henry for meeting with me every week. The project definitely wouldn't have been possible without his guidance at every step.